Equations and graphs of polynomial functions. Like I said, what we're doing now is taking all of that stuff that you've been learning for the last week and a half and putting it together into some different contexts. So one thing that you have to be able to do in this unit, which we haven't talked about yet, is to solve a polynomial equation. And do you know how an equation is different than a function? The function is when you have something like y equals x times x minus 4 times 2x plus 3. It's relating an x and a y value. An equation equals some value. And when you're solving an equation, you already know how to do two types. If it's linear, then you isolate the x. If it's quadratic, you factor, or there's the quadratic formula, or graphing. Are kind of three different ways that you learn how to solve a quadratic. This one's actually cubic, but we solve it similar to the way that we do a quadratic. Usually we solve by factoring. You could solve by graphing too, but we're going to solve this one by factoring, and the nice thing is it's already factored. If you have a polynomial function and it asks you to solve, make it equal to 0 if it's not already, and then factor. So this one's already equal to 0, already factored. So all we need to do is apply what we call the zero product property. And the zero product property says that if all these things multiplied together equals 0, then one or more of them have to equal 0. To get a product of 0, one or more of your factors have to be equal to 0. And that's why we can actually solve by factoring, is because of that zero product property. What we're going to do is take the first factor, make it equal to 0. Take the second factor, make it equal to 0. Take the third factor, make it equal to 0. If any of these is equal to 0, then the function, or sorry, the equation itself on the left is equal to 0. So one possible solution is that x equals 0. Another possible solution is when x minus 4 equals 0. What would x have to be equal to for x minus 4 to be equal to 0? Positive 4. That's just a little linear equation that you could solve. And then 2x plus 3 could also equal 0. What would x equal if 2x plus 3 equals 0? Negative 3 over 2. Subtract 3 from both sides of that and you get 2x equals negative 3. And then divide by 2. So we end up with x equals negative 3 over 2. Those are the three solutions to that cubic equation. X equals 0, x equals 4, and x equals negative 3 over 2. You don't necessarily have to write out those steps. If you can look at the factor and know what the answer is, then just do that. Like if I had this, I'd probably just write x equals 0, x equals 4, x equals negative 3 over 2. And it's okay to do that. But that's where they come from. It's by making each factor equal to 0. That's how you get the solutions. I'm going to ask you to solve another one. This is another cubic that I want you to solve. The method that we're going to use is solving by factoring. The way that we're going to factor, find the potential zeros, test them using the factor theorem, synthetic division, blah, 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 find the answer that way. Now that you've had a chance to try it, just to save time, P of 2 equals 0. Instead of going through, but you know where I got the 2? Do you know how I knew to try the 2? Those are the potential zeros. They're the factors of 24, the factors of the constant term. So I could test 1 and negative 1, 2 and negative 2, 3 and negative 3, 4s, 6s, 8s, 12s, and 24s. But I didn't have to test very many. Usually I try the small numbers first. So I tried the 1s, and they didn't work, so I tried a 2. You may have found a different 0 that worked, and that's okay. I didn't even try negative 1, actually. I think I just tried positive 1. But anyway, now I'm going to do the synthetic division with 2. So bring down that 1. 2 times 1 is 2. Add. So it's negative 1, multiply That's negative 2. Add them together, negative 12, and then multiply negative 24, and you end up with 0, which is what you have to end up with. If you don't, then go back and find your mistake. So what that means once we've done that, remember this is now the binomial multiplied by what we get here. So x minus 2 is a factor we already determined. The other factor is x squared minus x minus 12, and that equals 0. Now to continue solving, we factor the x squared minus x minus 12. That's fairly easy to factor, I think. It's just x and x. Doesn't have a coefficient on the squared term. So two numbers that multiply to negative 12 and add to negative 1. And those are negative 4 and 3. Is that what you got? Yeah? What's the last step once it's all factored? Make each factor equal to 0 so that you can find these solutions. So these solutions are x equals 2, x equals 4, and x equals negative 3. Here's something else that you could be asked to do that uses all that knowledge that you have. This says, without the use of technology, determine the zeros and their multiplicity, the end behavior, and the y-intercept for this function. This might be a little harder because it's not sort of exact steps like the last one was, but anybody have an idea of how to figure out any of that stuff? Factor it. So starting out exactly the same as we did the last one. This one only has 4 potential zeros, positive, negative 1, positive, and negative 3. So let's figure out, you guys test them and tell me which one works. So P of 1 is equal to 0, which means x minus 1 is the factor. We'll do that division with 1, negative 1, 5, negative 7, and 3. Bring down the negative 1 and then multiply, add those together, multiply, add them together, multiply, the remainder of 0. I know that's fast, but you guys should know how to do that part by now. So now what we have for the function is that f of x is equal to x minus 1 times negative x squared plus 4x minus 3. That's a little bit weird to factor, isn't it? That negative x squared plus. So I think what I'll actually do is factor out a negative 1. I'm going to put a negative in the front. This factor is going to stay the same. But because I'm factoring out a negative 1, this changes to x squared minus 4x plus 3, which is just more like what we're used to seeing. So it makes it a little easier to work with. And then I want to factor that, negative x minus 1. You could do the same thing, like you're saying, and find the potential zeros and do synthetic division again. But I think this one, it's easier just to factor because it's a quadratic by making two binomials. I think it'll save time. All we need to do is find two numbers that multiply to 3 and add to negative 4. And those numbers are negative 1 and negative 3. So we can actually write out the binomial like this, negative, and then x minus 1 squared times x minus 3. There it is, fully factored. Now we can probably start to answer some of those questions. So for A, what are the zeros? X equals 3, and x equals 1 with a multiplicity of 2. The B part asks you about the end behavior of the graph. Remember, when you're talking about end behavior, you need to think is it an odd or an even degree? And this one is odd, which means one end's going to go up and one end's going to go down. And then the leading coefficient is negative. So that actually means what? Extends up into quadrant 2 and down into quadrant 4. Now, this isn't, I don't have all of that information memorized about end behavior. One thing that you can do, although it says without the use of technology, so you have to kind of show where this stuff's coming from, but you could, graph it on your calculator and find out if you had a graphing calculator, but that's kind of cheating. But what I do to kind of cheat is think, okay, it's a cubic, and I know what a cubic function looks like, just y equals x cubed. Do you know what y equals x cubed looks like? It looks basically like that, right? And so I think this is going to be some variation of that. So I just know in my head what y equals x cubed looks like. And I know this is a positive, and so I know if it's negative, it's going to flip. So this one's going up into quadrant 1. This one, the one that we're working with, is negative, so it has to go up into quadrant 2. So I don't memorize everything. I just really, what I know is what those graphs look like. What y equals x squared looks like. What y equals x cubed looked like. What y equals x to the power 4 looks like. Those things. And really, it's all you need to know is x squared and x cubed. And if you can remember those, then you can kind of work off of those for any other functions that you're working with. That's what I do. We have one more thing, the y-intercept. Do you know how to find the y-intercept, where it crosses the y-axis? Set x equal to 0 and solve for y. This is an important skill because you know what? I see this one turn up on departmental exams a lot. Not this particular question, but it asks you for a y-intercept. I don't know why. They like that question. And anytime they're asking you for a y-intercept, just fill 0 in for x and solve for y. So we're finding f of 0. And if we find f of 0, it'll give us the y-intercept. So that's negative 0 cubed plus 5 times 0 squared minus 7 times 0 plus 3, which actually for a polynomial function, it's just equal to the constant term. Because all of these other ones, 0, 0, 0, when you multiply, you're left with just that constant term at the end. So the y-intercept is equal to 3. This one I want you to try on your own or with people that you're sitting with if you need help. This one was way easier to factor if you remove a common factor first. So I'm going to take that function and remove the common factor of x squared. We're left with x squared minus 81. And then x squared minus 81 is a quadratic, and I can factor that easily. It's actually a special quadratic. What is it? A difference of squares. So it factors to x plus 9 and x minus 9. Or you're looking for two numbers that multiply to negative 81 and add to 0, and those are 9 and negative 9. So now when I want to talk about the zeros and their multiplicity, x equals 0 from the first one, right? X squared equals 0, which means x equals 0, but it has a multiplicity of 2. Multiplicity of 2. And then we have x equals negative 9 from the second one, and x equals 9 from the third one. You could, at this point, start to get an idea of what this graph would look like, especially when we add in the end behavior and the y-intercept. The end behavior, this is an even degree polynomial because it's a degree of 4. and it has a positive lead coefficient, which means that it extends up into quadrants 1 and 2, right? Think of this as being similar to this function, which is y equals x squared, if it actually reached the bottom, because it's positive and even. And then the y-intercept, what's the y-intercept? 0. At this point, you should be able to get a pretty good picture of what that graph looks like. It has x-intercepts at -9, 0, and 9. There's a y-intercept of 0, and it's extending up into quadrants 1 and 2. This 0 has a multiplicity of 1. This 0 has a multiplicity of 1. So it's just going straight through those. But this one in the middle has a multiplicity of 2. So it should look quadratic there. So it does that. And then you can sort of piece together the graph, and you should know that it looks something like that. I'm not going to be able to draw a perfect graph with just this information. Really, I'm going to need calculus to be able to draw a really good graph. But it certainly gives you an idea of what the graph should look like. Those of you that are taking calculus will do a section on curve sketching, where you'll get a lot more information about how to graph, but this is kind of the beginning of that. All right, one last thing that we could do with this. Write the equation for the function shown here. We should have an idea of what the equation is going to look like. It's a polynomial function. If we know what the zeros are, then that's going to help us. I'm going to go y equals A is the lead coefficient. I don't know a lot about the lead coefficient right now, except I do know that it's positive because it's extending up on both ends. My zeros are -1, so that gives me a factor of x plus 1. What's the multiplicity of that one? 1, because it's just going straight through. And then I have another 0 of 3, so x minus 3. And what's the multiplicity of that one? 3. Because it looks cubic at that point. It switches its concavity there. So that gives me something that's fairly close to the equation. I just need to figure out what that A value is. Do you know how to do that? Choose a point, did you say? Yep, and it gives us one, right? So we'll use that one that we know. 0 and -6.75. I'm going to fill that in for x and y and solve for A. So y is -6.75. A is A. X is 0. It's easiest if you always use the y-intercept if possible, because then these factors become much simpler. Doesn't matter, you could use any point on the line except for one of the zeros, because we already used those. So this is 1, and this is -3 cubed, which is equal to -27. So -6.75 equals -27a. Divide by -27. And we get A is equal to 0.25, or 1/4. Which means the equation of that function is y equals 0.25, or 1/4 x plus 1 x minus 3 cubed.